Hi everyone, let's work on the review for Chapter 7 test. First question is asking us to simplify this. In order to simplify this expression, we need to multiply both top and the bottom by the conjugate of the bottom because we want to get rid of the I in the denominator. What is conjugate of the bottom? You're going to write the same terms that you have, -6, the first one, and 2I is the second one. And instead of putting a negative, you put a plus between them. So this is conjugate of this term. Now you multiply both and top and the bottom by conjugate of the bottom. So the same thing on top and the bottom. Now distribute and simplify. 6 times -6 is -36. 6 times 2I is 12I. I times -6 is -6I. I times 2I will be 2I squared. The denominator, I have -6 minus 2I, -6 plus 2I. We have learned this identity before, that if you have A minus B times A plus B, when you distribute and simplify, you're going to end up having A squared minus B squared. This is the difference between squares. So we're going to use the same thing. Just take each term, -6, and raise to the power of 2. -6 to the power of 2 is 36. And 2I to the power of 2 is 4I squared. And put a negative between them. Now it's time to simplify. We know I squared is -1. So 2 times -1 will be -2. Now -2 and -36 will be -38. 12I minus 6I is 6I. Again, here in the denominator, I squared is -1. -4 times -1 is +4. Now 36 plus 4 will be 40. So I'm just going to write 40 here for you. So as you see, we don't have I anymore in the denominator, and that's what we want basically. Now it's time to simplify one more step. Everything here is divisible by 2. This divided by 2 is 20. Divide by 2, 90. Divide by 2, 19. Divide by 2 is 3. So -19 over 20 plus 3 over 20I. This is my answer. Okay, next we want to solve this equation. The first thing that I'm going to do is add 6 to both sides. So I will have 3x squared equal to 6. Then divide by 3. So x squared will be equal to 2. Now we take the square root of both sides. The power of 2 and the radical cancel each other. So x will be positive root 2 and negative root 2. Okay, now we want to find the transformations of this function. If you have a x minus 3, that means your function have been moved right for 3 units. I have a negative here, that means we have a reflection across the x-axis. And I have a +2, which is outside of the function. That means your function is moved up 2 units. Okay, now we want to solve this equation. We're going to subtract 16 from both sides first. So we have x squared equal to -16, and then we take a square root of both sides. These two cancel, and now x is positive square root of -16 and negative square root of -16. However, we know that we cannot have a negative on the radical, but we can write it as a complex number in terms of I. So I'm going to rewrite this. -16 on the radical is basically -I times square root of 16. It's basically negative 1 times square root of 16. Square root of negative 1, we know that it's equal to I. I is the square root of negative 1, and I squared is equal to negative 1. So instead of this term, I'm just going to put I here. And the square root of 16 is 4. So I can just write 4I here. And the same here. I have a negative outside, and I write negative 16 on the radical as negative 1 on the radical and 16 on the radical. So I know this is I. I have negative I times the square root of 16, which is 4. So this is negative 4I. Okay, now we're going to multiply these two. Again, since we know we cannot have a negative on the radical, we're going to write this as a complex number. So square root of negative 4 is negative 1 times square root of 4. That's the first one. The second one is square root of negative 1 times the square root of 16. And I'm going to write this as I. Square root of negative 1 is I. This is also I. This one is 2. This one is 4. So when I multiply them, 2 times 4 is 8. I times I is I squared. But I know I squared is equal to negative 1. So I can write this as 8 times negative 1, which is equal to negative 8. Okay. Transformations of this function. The parent function is x squared. So we're going to start with graph of y equal to x squared. We're going to shift this left 2 units because I have plus 2 with x next to the x. So this is left for 2 units. And since I have a negative, I have a 1 over 2 that is multiplied outside of the function. So that means this is vertically shrink because 1 over 2 is less than 1. So this is shrink. By multiplying each y value, because we're shrinking vertically, that means the transformation is happening to the y value by 1 over 2. That's the scale factor. And then reflect across the x-axis because we have a negative here. This negative makes it reflected over x-axis. Okay. The next function here, I have 1 over 2 multiplied by absolute value of x. So we know that this is our parent function. This 1 over 2 is going to shrink your function vertically by a scale factor of 1 over 2. And then we have a negative 5 outside of the absolute value. This is outside of the function, so it's going to move your function down for 5 units. So which one is the graph of my function? I know absolute value function looks like this. It's kind of V form. Now, first of all, I shrink this by a scale factor of 1/2. That means it's going to be shorter and wider. And then I need to move it down 5. So that's going to be this one. It's moved down 5 units, and also it's short and wide. So this is your answer. Now we want to find the answer to this operation. All we need to do is distribute and simplify. 5 times 5 is 25. 5 times negative 3i, negative 15i. 3i times 5 is positive 15i. And 3i times negative 3i will be negative 9i squared. Okay, now simplify. Negative 15i and positive 15i cancel. So I have 25 minus 9i squared. But I know I squared is -1. So this will be 25 minus 9 times -1 will be -9. And I have a negative here. That's going to make it +9. So the answer will be 34. Okay, now we have graph of y equal to x squared, and it's upside down. That means reflected over x-axis and shifted 3 units to the right. So if I'm shifting the function 3 units to the right, that means I need to subtract 3 from x. This is what is happening inside the function. And it's upside down, so you're going to put a negative behind that to reflect it over x-axis. So this will be your answer. We want to simplify I to the power of 32 here. So all we know about I is I to the power of 2 is equal to -1. So we're trying to extract I to the power of 2 from this expression. So you know that I squared to the power of 16 will be equal to I to the power of 32. Because if you have power of power, like for example, x to the power of a to the power of b, you're going to multiply the power. So this is a times b. So I can go to the other way. 2 to the power of 16 means I to the power of 2 times 16, which is 32. Okay, now I know I squared is -1. So inside the parentheses, I have -1 to the power of 16. Now I have a negative number to a power of an even number. We know any negative to the power of even number makes it positive. For example, -1 to the power of 2 is -1 times -1. And negative times negative makes it positive. So any negative to the power of even number makes it positive. So this will be equal to +1. So 1 is your answer. Okay, now we want to multiply these two. Just distribute 8i times 8 is 64i. 8i times -9i will be 72 times I squared. Now, I know I squared is -1. -1 times -72 makes it +72. And I have a 64i. So this is my answer. Now we want to solve this equation by completing this square. So in order to solve it this way, this is what I'm going to do. X squared plus 6x. I need to add something to make the left side a perfect square. And this is -8 on the right side. What am I going to add here? That's the b value, which is 6 here, divided by 2 raised to the power of 2. This is what you're going to add here. So that's going to be 6 divided by 2 to the power of 2. This is 3 squared, 9. So you're going to add 9 here. But since you have added 9 on the left side of the equation, you're going to add that to the right as well to keep the balance. Now it's time to make the left side as a perfect square. What are you going to do? Just take a square root of the first term, which is x. Square root of the third term, this is 3. And take the sign that you have here, move it down here, plus 3. And the right side is -8 plus 9, which is 1. So now we have x plus 3 squared equal to 1. In order to solve for x, you take a square root of both sides, the power 2 and radical cancel each other. You will have x plus 3 equal to positive square root of 1, which is 1, and negative square root of 1. Now you solve for x minus 3 minus 3. X will be equal to -2. And here x will be equal to -4. So these are the answers. Okay, next we want to solve this equation. For this question, I'm going to solve using factoring. So I'm looking for two numbers that if I add them, I get -7, which is the b value. If I multiply, I get a times c. What is a times c? That's coefficient of the first term is squared times c, the constant term. So this is a, this is b, this is c. So 1 times -8 is -8. So you're looking for two numbers that add up to -7 multiplied to -8. Those two numbers are -8 and 1. Now, since the a value is 1, I can easily just write s minus 8 and s plus 1. Just write these two numbers here equal to 0. Now, in order to solve, just set each factor equal to 0 and solve s minus 8 equal to 0. S is 8. S plus 1 equal to 0. S is -1. Now we want to multiply this. Just multiply 3 plus 9i times itself, because it's to the power of 2, and distribute and simplify. So 3 times 3, 9. This will be 27i. This will be again 27i, and this one will be 9 times 9, 81. I times I is a squared. Now I know a squared is -1. So this will be 9. 27i plus 27i will add up and will be 54i. And 81 times -1 is -81. Now I need to combine 9 and -81. So I'm going to write 9 and -81 will be 78 negative. Sorry, I made a mistake. This will be -72. 9 minus 81 will be -72, and a 54i after that. So this is your answer. Now I want to solve this equation. The first thing that I'm going to do here, I'm going to move everything to one side. So 3x squared, and I'm going to write them all in order. So x squared, then x, and then plus 7 equal to 0. And I want to solve this. The first thing that I can think of is factoring. So I'm looking for two numbers that if I add them, I get -5. That's the b value. If I multiply, I get a times c, 3 times 7. That's 21. But I cannot find two numbers that if I add get -5, multiply get 21. So I cannot use this method. So I'm going to use the quadratic formula. What is that? It's -b x equal to -b plus and minus b squared minus 4ac divided by 2a. What is a, b, c? A is coefficient of x squared, this is b, and this one is c. So I'm going to start finding the answer. X will be -b. That's negative times -5 makes it +5. Plus and minus b squared is -5 squared is 25 minus 4 times a, which is 3, times c, which is 7, divided by 2 times a, which is 6. Okay, so this will be 5 plus and minus 25 minus this number, 4 times 3 times 7, will be -59 divided by 6. So this is my answer, but since I have a negative on the radical, I need to take care of that negative. So what do? As you see, negative on the radical makes us use the I. So I can write 5 plus and minus square root of -1 times the square root of 59 over 6. This is I. So I can write my answer as 5 plus and minus I square root of 59 over 6. So these are my answers. Okay, next one, we want to find the vertex of this quadratic equation. So how do I find the vertex of a quadratic equation? We know that the x of the vertex is always at negative b over 2a. So this is x of the vertex. That's negative times negative 10 makes it positive 10, and 2 times a, and a is 1 here. So that's 2. It's equal to 5. So the x of the vertex is at 5. Now I need to find the y value of the vertex. How do I find that? Just plug in this 5 into the equation. So you need to find what is f of 5. So it's going to be 5 squared. Wherever you see x, plug in with 5. Negative 10 times 5 plus 24. So this is 25 minus 50 plus 24. So this will be negative 25 plus 24 is negative 1. So the y of the vertex is at negative 1. Now, determine whether the parabola has a maximum value or minimum value and find the value. So we want to find the max or minimum value. Well, first of all, the parabola is going to be upward. How do I know that? By looking at the a value. The coefficient of x squared is 1. If the coefficient of x squared or a is greater than 0, your parabola is upward. If a is less than 0, your parabola is downward. So I know this is upward. And if my parabola is upward, the vertex which is at this point will be the minimum point. So we have a minimum point because the parabola is upward, and the value of minimum is the same as vertex, so it's negative 1. The value of minimum is negative 1. You just need to take the y value of the vertex. Now it's asking us what is the range of the f of x. In order to find the range of f of x, I'm going to draw the graph. It's not going to be an accurate graph, but it's okay. It can help me find the range anyway. So I know the vertex is at 5 and negative 1. So let's say 1, 2, 3, 4, 5 and negative 1. This is my vertex. And I know the graph is upward, so the graph is going to look something like this. And I don't care where it's crossing the x-axis because I don't really need it at this point. Now, to find the range, you need to move from bottom to top and look for the y values. Where does the y value, the first y value happen? It happens at this point, which is at negative 1, because this point is 5 and negative 1. So the first y value as you're moving from bottom to top is negative 1. So you start from negative 1, and I'm going to put a bracket because this point is part of the graph, it's included. And then after that, I see the graph is going to continue forever, goes to the positive infinity direction. So negative 1 to positive infinity is the range. Now it's asking us on what interval the function is increasing. So the increasing part of my function is this part. From the vertex to the right side, this is moving up. And on the other hand, this one is moving down. This is decreasing, this one is increasing. So in order to write the increasing interval, you just need to write x of start and x of end of your function. So where is x of start? It's at 5. X of end will be infinity because the function is going to continue forever. So from 5 to infinity, the function is increasing. And decreasing area is this part. So x of a star, we are always going to move from left to the right. X of a star will be this side. Starts from positive infinity, parenthesis, and ends at 5 this time. So this time we go from left to the right. This is a start and this is end. So I'm sorry, this I was supposed to write 5 to 5. So this is your decreasing interval. Okay, next question. A graph is given. The x-intercepts are these 2 points. So one of them is, because it's asking us to write as ordered pair, one of them will be -3 and 0. X is -3, y is 0. The other one will be 5 and 0. The zeros of the function are the same thing. So you're going to use the same points as the zeros as well. Because x-intercept and zeros are both the same concept. Okay, let's go to next question. We want to multiply these. Again, just distribute and simplify. I'm going to leave this for you because we have done several of these problems before. Okay, this function, is this function even, odd, or neither of them? So we know a function is odd if it's symmetry to the origin. So I'm just going to look at my function. This is my origin. If I consider any point of my graph, do I see a mirror of that on the other side? That means I draw a line to the origin and continue the same amount on the other side. Do I see a point on the graph? Yes. Any point here, I'm going to consider this one now. This one has a mirror on this side. Even here, this one has a mirror on this side. I'm going to try it again for you. I connect to the origin and go to the same direction over here. So everything has a mirror on the over the origin, on the other side of the origin. So it's odd. It's not even. Even is when your graph is symmetry to the y-axis. That means left and the right side are exactly like each other. But as you see here, although it might seem a little bit similar, but they're not exactly the same. So if this is the point on the right side, there is no mirror of that on the left side of the y-axis. So this is not even, and of course, not the other. Okay, this one we want to solve with completing this square. So I'm going to write 3z squared plus 5z, and I move the 2 to the other side. The 2 is here. Now I need to add something here to make this a perfect square. But before that, this is what I need to do. In order to complete the square, we don't need a coefficient for z squared. So I need to get rid of this. So what do? I'm going to divide everything by 3. So I get rid of this coefficient of z squared. So my expression is going to look like z squared plus 5 over 3z plus, and I need to add something here equal to 2 over 3. Now let's see how we can solve this. Again, the same as what we have done before. You just take the b value, which is 5 over 3, divide by 2, and raise to the power of 2. This is going to be here. So what is that? It's 5 over 3 divided by 2. You do keep, change, flip. So 5 over 3, the division will be multiple, and flip the 2, it's 1 over 2. So this will be 5 over 6. Now you raise that to the power of 2. That's 25 over 36. So 25 over 36 is the term that I'm going to add here. and I'm going to add that to the other side as well to keep the balance. Okay, now it's time to make the left side a perfect square. Square root of z squared is z. Square root of 25 over 36 is 5 over 6. And this sign will be here, which is positive. Now, what is the right side? I need to add these two. I have two fractions, but they don't have the same denominator. So I'm going to find a common denominator. You need to multiply 3 by 12 to get 36. And you do the same thing to the top as well. So this will be 24 over 36 plus 25 over 36, which the answer will be 49 over 36. Okay, now time to take a square root of both sides. You have z plus 5 over 6 equal to positive 7 over 6, because you take a square root of this number, 7 over 6, and z plus 5 over 6 equal to negative 7 over 6. Now, subtract 5 over 6. So this one will be 2 over 6, which is 1 over 3, and this one will be negative 12 over 6, and the answer is negative 2. So these are the answers. Okay, next we want to know if this function is even or odd. Well, as you see, any point on the right side has the mirror on the left side. So this is symmetry to the y-axis, and that means it's even function. Now we want to know if this function is even or odd or neither of them. So one way to find that is to graph your function and see if you have a symmetry to the y-axis or to the origin or not. The other way, you can use algebraic method to solve it. So how do I use the algebraic method? I'm going to find f of negative x and see if it's equal to f of x or not. So is f of negative x equal to f of x? Let's try that. F of negative x means wherever you have x, plug that with negative x. So I have 3 times negative x to the power of 3 plus 2 times negative x to the power of 5. Negative x to the power of 3 will be negative x cubed. And I put the 3 here. Negative x to the power of 5 will be negative 5. Negative x to the power of 5. That means negative x to the power of 5. And I put the 2 here. Because a negative number to a power of an odd number will be negative. Okay, now I can factor the negative out here. This is 3x to the 3 plus 2x to the 5. But as you see, this is not equal to f of x, because f of x is this. It doesn't have a negative. So this is not even. Is it an odd function? So in order for function to be an odd function, I need to check if f of negative x is equal to negative f of x or not. Okay, so we already have the negative f of x, which is negative 3x to the 3 plus 2x to the 5. This is what we just found. And what is negative f of x? Just write your function and put a negative behind that. 3x to the 3 plus 2x to the 5. And as you see, they are exactly equal to each other. So this is an odd function. Okay, next we want to shift this function left 4 units and up 3 units. So for left 4 units, you need to add 4 to the x. So it could be one of these two. And up 3 units, add 3 outside of the function. So that's your answer. Next, we want to simplify I to the power of 27. Again, we're using the same method. I squared equal to negative 1. So see if you can find I squared here. Because this is an odd number, I'm going to write that as I to the power of 26 times I. We know that if you have x to the power of a times x to the power of b, you keep the base and add the powers. So I'm going to the other way. If I have x to the power of a plus b, I can write it as x to the a, x to the b. The power of I here is 1. 26 plus 1 is 27. Okay. On the other hand, since I squared equal to negative 1, I'm going to look for I squared in the first term. This is I squared to the power of 13, because 2 times 13 makes 26 times I. Okay, I know I squared is negative 1, so negative 1 to the power of 13 times I. Negative 1 to the power of an odd number keeps it as negative 1. Negative 1 times I will be just negative I. So this is your answer. And here's the last question. We want to subtract and simplify. In order to subtract, the first thing to do is distribute the negative here. So I'm going to rewrite. The first term will be the same, 7i and 10. The next one will be negative 9 and negative 4i. So the negative belongs to both of these two terms. Now it's time to simplify. Combine the like terms. Negative 9 and 10 makes it 1, and 7i and negative 4i is 3i. So this is your answer. Okay, this was the last question. I hope it was helpful. Have a great day.